Until now, we pictured displacement as one arrow from the initial position to the final position.
Now we will place that arrow on a coordinate axis and study motion along one straight line.
Imagine a straight road. First, we choose one physical point and call it x equals 0. That point is the origin. Then we choose one direction as positive. For example, we can choose the direction to the right as positive x.
Only after making those choices do the road positions receive coordinate numbers. Positions to the right of the origin have a positive coordinate.
For example, x equals plus 2 meters, plus 5 meters, or plus 10 meters.
Positions to the left of the origin have a negative coordinate. For example, x equals minus 2 meters, minus 5 meters, or minus 10 meters.
Be careful with the meaning of that minus sign.
A negative position does not mean a negative distance.
It does not make the object less real.
It only means that the object is on the side opposite to the chosen positive direction.
5 meters to the left is still a real length of 5 meters.
The coordinate axis is a convention. We choose where 0 is, and we choose which side is positive. If we move the origin, or reverse the positive direction, the coordinate numbers change. But the road, the landmarks, and the physical object do not move.
The convention changes the description, not the real situation.
Now we need another careful distinction.
Position and displacement are not the same quantity.
Position tells us where the body is. Displacement tells us how its position changed.
To show position, one point on the axis is enough. To show displacement, we keep the initial position, mark the final position, and draw one arrow from the initial point to the final point. For straight line motion, the sign displacement along the x-axis is delta x equals x final minus x initial.
The symbol delta means change.
So delta x means the change in position x. Xi, read as x initial, is the initial position. Xf, read as x final, is the final position.
The formula says one simple thing.
Displacement equals final position minus initial position.
Here is the first example. Suppose the body starts at x initial equals 2 meters.
It finishes at x final equals 8 meters.
Then delta x equals 8 meters minus 2 meters, which equals plus 6 meters. The displacement is positive because the arrow points in the positive direction of the axis.
Now reverse the motion.
The body starts at x initial equals 8 meters.
It finishes at x final equals 2 meters.
Then delta x equals 2 meters minus 8 meters, which equals minus 6 meters.
Notice that both positions are positive.
The final coordinate is plus 2 meters, but the displacement is negative.
So delta x less than 0 means that x final is less than x initial. It does not mean that x final must be less than 0. The minus sign describes the orientation of the displacement arrow.
It does not describe a negative traveled length. For this direct motion from 8 meters to 2 meters, the distance traveled is 6 meters.
The displacement is minus 6 meters. And the magnitude of displacement is 6 meters. Distance traveled can never be negative.
In symbols, s is greater than or equal to 0.
The sign of delta x gives the orientation along the chosen axis. If delta x is positive, the displacement points in the positive direction. If delta x is negative, the displacement points in the negative direction. If delta x equals 0, the final and initial positions are the same. That does not necessarily mean that the body never moved.
It may have moved away and then returned to its starting position. Now compare the two 6-meter examples.
Moving from 2 meters to 8 meters gives delta x equals plus 6 meters. Moving from 8 meters to 2 meters gives delta x equals minus 6 meters.
The two displacement arrows have exactly the same length, but they point in opposite directions. That is why the displacements are not the same.
Delta x equals minus 6 meters is assigned displacement. The magnitude, written as the absolute value of delta x, equals 6 meters.
The vertical bars mean that we take the magnitude without the sign. If we ask, how long is the arrow, the answer is 6 meters. If we ask, which way does the arrow point, the sign matters.
So remember the complete picture.
Position tells where the body is on the chosen axis.
Distance traveled adds the length actually covered and is never negative. Displacement compares the final and initial positions, and its sign gives orientation. The magnitude of displacement is the non-negative length of the displacement arrow.
This distinction prepares us for motion problems with negative coordinates, reversals, and different coordinate conventions. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments.
We will do our best to answer it.